Okay, so hello again, everyone. So for, well, the final talk before our discussion, we are having a presentation from Brian Maranville on compression plugins in h5wasm. So he's presenting remotely.
Good afternoon, I guess it is, where everybody is there. Thanks for the opportunity to talk about compression plugins in sort of a different architecture than a lot of these talks have been about Python and installing on more hard iron architectures for servers and things like this. But I'm going to talk about what you might use it for on the web. So this is sort of a very, very brief history of how we started using HDF files on the web. We have a lot of HDF files in our Nexus data files. Well, for us, it's a lot, I realize. For other facilities, this will seem like a small number. But we have, nearly 700,000 Nexus data files that are public. Our data policy is such that the raw data files are made public immediately. So we pipe them out into an HTTP server as they're taken. And there was a desire to let users take advantage of this right away so they could see their data files and interact with them immediately as soon as the data was recorded. And then this also gets used as sort of the primary source for doing further processing steps. They can access it directly through REST interfaces using HTTP to grab their files and do things with them. So there was a desire to view the raw data files, which are in Nexus format HDF5, and then also user-generated files. So processing tools that are available create new HDF files from the Nexus inputs, and these files don't belong to our facility. And so we wanted a viewer solution that would allow users to look at their own data files on their own systems, in addition to the ones that are hosted at our facility. So, and have them use the same viewer for both of those. And we had traceability requirements. So there were a few reasons that we wanted to go with sort of a HDF5 file-based solution rather than HSTS, which is very nice for other things. So what we chose is to make a browser native viewer, and then we needed a backend that could read HDF5. And my first stab at this was to port Pi5, which is a pure Python direct implementation of the HDF5 spec. Pardon me. But it's very limited in its coverage of the specification. You can read, a lot of data sets, but not all of them. I mean, there are a lot of features that aren't enabled in the spec. So adding to it is very time consuming, as you can imagine. It does support the zlib compression. So that's one thing that was able to be shoehorned in there. But then over time, moved towards really wanting to access the HDF5 API directly. So I looked into building the HDF, sorry about that, the libhdf5 with emscripten into a WebAssembly library. And this took some time for me to figure that out. In the end, it's a lot simpler than I thought it was, but that's the route that we ended up taking. And so we started with, for the front end, we had a viewer that I had created with jQuery and stuff sort of pasted together. But then I noticed that there was this development underway at Panosk to make this H5 web product that was very nice. And so I contacted them, and in the best spirit of open source, we worked together to include the h5wasm backend so that data files could be read directly in the browser with their beautiful front end. So this was a collaboration that started, I think, early last year in 2022, and the integration, I think, was complete before the end of last year. So what is h5wasm? It's a JavaScript and WebAssembly library for HDF5. It has some high-level utilities that are modeled after, loosely based on what's available in H5 Pi. Obviously, a much smaller set. It's development is not as it's a much smaller project, but you can read or create groups and data sets and attributes. A subset of different data types are available. And then it works by calling low-level functions that are compiled into the WebAssembly library that actually directly accesses the HDF5C API. And so the backend library is compiled against a pre-built, there's sort of another step below that, libhdf5, which is compiled to the WebAssembly target. And that's a project that I actually got help from another collaborator who helped package that up so that could be reused for other projects. And then I think he's reusing it for something else. He's not even using h5wasm, but is using libhdf5wasm. So the source for this h5wasm is here, and then at this GitHub repository at the bottom. I don't know if you can see my mouse. And then the package for installing it, if you want to just install it, you can use npm. I don't know how many of you use node packages, but if you want to install the package, all you have to do is just do npm install h5wasm, and you get the whole thing, and it works out of the box. And you can use it in Node locally, or you can use it in a browser if you bundle it up. So I'm just going to go a little bit into what emscripten is. So it's a compiler system that compiles C and C++ sources or any language using LLVM to WebAssembly. And then it also provides a JavaScript loader, which is very useful because it includes an emulated file system in the browser. Or in Node, it can use the raw file system of the OS, or it can use an emulated file system also. And this is obviously a good fit for HDF5 because it's C, so it can be compiled directly. And then also having the file system directly available because HDF5 libraries are expecting to interact with a file system. So this allows you to compile libhdf5 to WebAssembly and then use it. And then also in the JavaScript loader, there's an API for calling those functions that are in WebAssembly and then using pointers and things like that. So there's a little bit of low-level stuff that goes on. And then relevant to this talk on plugins, as I'll get to later, there is some support for dynamic linking. There's some flags that you can pass to the compiler that allow you to do something like dynamic linking. And then to use it, it's very similar to using make or cmake. You just wrap those up. You say em cmake instead of just cmake, and use em make to use the other tools after you've installed emscripten. So who's using h5wasm? Well, as I mentioned, there's an integration with the Panosk h5 web, and I think the difference between my HDF5 and Panosk h5 web is small because I think they're both developed by the same developer team, so they have similar capabilities. And I still have my old viewer that's running here at the NST Center for Neutron Research, but this is going to be deprecated, and we're going to use the Panosk viewer as well. We've had some issues with our reactor, so we're a little delayed on making new data, but this will be up and running pretty soon. So recently, there's been a request for adding compression plugins. h5wasm supports the zlib compression. It's compiled in as it is in a lot of systems. But people have been asking about, well, what about other compression types? Because a lot of people like to view files that have these other compression types in there. And the first one that was asked for, I think, was actually ZFP, but that was requested in a different repository. And then the one that was asked for directly on h5wasm was for ZStandard. So that was the one that got the ball rolling. And then there was an issue that got started for my HDF5 where we started talking about, what would we need to do to start supporting compression plugins for h5wasm. So a couple of steps have already been taken. The first one that needed to get done was to compile the main library so that it could be linked against. And so that was just adding a compile flag, main module. And so as of, a few months ago, or I guess that's a while now, as of May, it's compiled in that way. So if you have a recent version of h5wasm, you can do dynamic linking with it. And if you are able to compile a plugin, you can add the side module flag to the compilation. And then to use it, you actually have to load it into your emscripten file system. So you have to upload it to the browser. And then, obviously you could automate this process, but and then put it into the usual destination path and user local HDF5 lib plugin. So I started working on this. And so as an example, I tried building the ZStandard plugin. So I started from the plugin sources that are in HDF5 plugin. This was a good place to start for a couple of reasons. It was one of the first ones that was asked for. And also, it only has 2 source files, and it only has 1 dependency other than HDF5. So this was a good place to get started to put the training wheels on. So I made some adjustments so that it could be built with emscripten. And then I'll show you what those differences are. So I'm going to dive a little bit into, I apologize here, this is a little bit in the details of the build process, but I'm going to explain as I go along here. So I'm going to build it with cmake, and so I'm adjusting things in cmakelist.txt. This is a file that you use to control the build in cmake. And the first thing I did was use the fetch content system to grab the HDF5, libhdf5 library from GitHub directly. You can grab things by URL, and then you can give it a hash, so you make sure that you're grabbing the right thing. And then when you use fetch content make available, it actually downloads that and then puts symbols in the right places so that when you use this as a dependency, it will get compiled in. So because this is a precompiled library, it just grabs the .a file that's been compiled and links against that at a later step in the process. So then adding libzstandard, this is from Facebook, as somebody else mentioned in an earlier talk. So you just go to the GitHub site for Facebook, grab ZStandard. You have to give it a little bit of help. You have to tell it where the CMake folder is. This is just one line there, source subdir, and then tell it which version of ZStandard to build against. I picked a recent version 1.5.5. And then there's a couple features that I turned off because emscripten doesn't have, it has a very convoluted multi-threaded support system that we're not going to use right now that involves web workers and things. And then I didn't want it to build standalone binary programs because there's no use for those in the emscripten environment. And I want to build a static library so it can be linked against the plugin. And then again, the last make available just pulls it into the CMake system. And then build a target. So this is just setting everything up, telling it which sources to use, telling it which output name to use. And then this seems like an important, an important thing is to use position independent code. I think this, going forward for a lot of the libraries, building a lot of the dependencies with PIC seems to be an important thing to get everything working properly. And I apologize, I'm not a CMake expert. I realize that speaking to people from HDF group, there are some wizards with CMake who are probably, yeah, I'm doing the best I can. So this is how I got it working. And then at the bottom here, we use target link libraries to tell it which sources, which libraries I want to link in. And then in the end, I had to add a custom target so that I could do something a little bit non-standard in CMake, which is to run emcc, which is the emscripten compiler, again, after it had compiled the static libraries and combined them into a shared library. And I couldn't find a built-in CMake command to do that, so I just added a custom target. And so then it just pulls those together using, and there's that side module flag. You can see under CMake ccompiler -s side module lib h5z ZStandard, et cetera, et cetera. So that's what tells it to build it as something that's dynamically linked. And then it needs to, so some of the symbols will be defined in the main module, and it's expecting to find the HDF5 symbols in the main module, and so it doesn't export all those directly from the side module. And then the process to build it, in a shell, you just run emcmake and create a build directory, and then change directories to the build directory, and then make install, and it builds everything. And then you get a static library, libzstandard.a, so that's the dependency library, and then the plugin is again a static library, and then it combines them both into the SO file. And then I made a quick test, which I can't show here very easily because it's running on the web, but it read a data set made with the plugin, and it was able to read it. So I wrote it with HDF5 plugin and h5pi. I wrote out a test file that has a lot of different, well, I wrote out one that writes all the different available compressions, and then I tried to read the ZStandard one, and that worked great. It was able to read it, so it was able to load the plugin and read it. So building on this success, I thought, let's try LZ4. This seems like another easy one. And the compiling worked fine. I was able to do some similar steps where I adjusted some of the build options. It's a very manual process, try build, see if it works. But I was able to get it to compile, but then it wouldn't run. So I loaded it into a web page, and it started having runtime errors. And doing some detailed debugging in the console log of the browser, I found that it was running into symbols that it couldn't find. And so I tracked those backwards and found that it was missing some of the symbols from inet, which are used in the LZ4 plugin. So it needed some of these. And so the only way I was able to get it to work was to add these to the exported symbols from h5wasm. So right now, h5wasm doesn't export every symbol. It's set up so that when I use main module equals 2, this is designed so that you have to explicitly say which symbols are going to be exported. So I added these to the list of things that were exported. And so the library size increased by a few kilobytes, but it's still around 3.3 megabytes, which I understand is still big for some people that are loading things on the web. but it's smaller than if you export all of the symbols, which I'll show in a little bit later on. I'll talk about what happens if you export all the symbols. So after doing that and rebuilding, I published a new version of h5wasm that had these symbols exported, and then it worked. So this is sort of the process that I've gone through to make those first two plugins. So then talking about these extra symbols, this is an issue that'll come up as we try to add more plugins. So there may be missing symbols that are needed, and so there's one solution is to just keep adding new symbols to h5wasm. That's solution 2 down here. It'll slightly increase the size of the library, but it'll still keep it pretty small, I think, but it sort of ties the development of the plugins to releases of h5wasm. So we'd have to keep updating. And this is fine. I think this is probably a reasonable development model. It keeps the size of the libraries as small as possible. There's another solution where you set main module equal to 1. This is just another setting available in emscripten where it says export everything. When you do that, it exports the standard library stuff and also I think all the symbols it finds in the HDF5 library. And then that increases the size of the WASM file to 9.6 megabytes. So it's about 3 times bigger. So that's a decision that can be made as people decide how to deploy these things. For ease, you could just export everything and then you can build whatever plugins you want and just use them without having to recompile the main library. Early on in this presentation, when I started writing this presentation, there was an issue with Chrome where it would refuse to load plugins in the main thread. So if you loaded this script in the main part of your page, it wouldn't load any of the plugins because there was a 4 kilobyte limit to the size of any dynamically loaded WebAssembly that it would load. And then somebody got around within the Chrome code base while I was working on this talk, and they're like, oh, this is too small. And so they updated it. And now new versions of Chrome allow you to load 8 megabyte WebAssembly modules. So this is no longer an issue. I just have it in here because it happened while I was working on the talk. So as far as I can tell, Firefox and Safari don't have this limit, haven't ever had this limit the same way that Chrome did. So now people should feel free to develop these plugins. It seems like none of them are going to approach 8 megabytes. The first 2 that I've compiled so far have been less than 1 megabyte. So it's like full steam ahead. We can start developing plugins and we won't run into any of these limits. It looks like things are working. So if we want to strategize about how to make plugins widely available so that people can visualize data from a lot of different sources, it makes sense to do something like what's been done for HDF5 plugin for H5Pi, something like that for h5wasm. So if we had a public repo, this would be useful. And we'd need help from people who know about emscripten, CMake. CMake is hard. There's a lot of documentation and I struggle with it, but it seems very useful for this situation. Down the road, we might want GitHub Actions for automating builds and testing. And then what's really needed is that people who understand the details of the various HDF5 plugins that are going to be built, because building them can be tricky and people who have experience building them in other contexts may be able to troubleshoot building them in this new context. So that's something that would be very useful for this effort. And then finally, of course, deploying everything similar to the way the h5wasm is deployed. You can just send it to npm.js and then put it on GitHub and make it easy for people to get to the plugins and use them. So while I was working on this, I sort of made a stab at this, and I've started a repository that's, you can see the address there. And so far I've compiled ZStandard, LZ4, and vzip2 based on the sources in HDF5 plugin. And they work, so that's great. But they're not packaged in a way where it'd be easy to use them in another system, and they're not published to NPM, and there's no tests, and dealing with the plugin path. In the browser, it's fine to have the plugin path be user local, HDF5, etc., because it's a virtual file system. You can create that path with no issues. If you're going to use this in Node.js on a real file system, you may want to use the facility of specifying a new plugin path. So that's something that we could add, and then maybe have it automatically install itself as adding that path to the list of paths that it searches when you first import the library or something like that. I'm not quite sure how HDF5 plugin does this, but we could do something similar, or maybe something that's specifically appropriate for the browser environment or the Node environment. So to make these sustainable, well, at the moment, I'm the single maintainer for h5wasm, and there's been people who have done PRs and provided a lot of help, but there's kind of a choke point in that it's in a private organization at the place where I work, usnistgov, and there's not really anybody else at my facility that is seems interested in helping on this or taking over. So it might make sense to move this to an organization in GitHub that's outside of usnistgov so that other people can directly contribute and can have administrative privileges on the contributions. I've gotten this library to the point where it fulfills the needs that we have at our facility. We don't actually use a lot of plugins. Our data files are relatively small and have a lot more data sets. They're sort of heavy on the metadata side and less heavy on the actual data side. So it would be great if this became more of a community effort. So we could move the h5wasm main repo, the libhdf5 repo, and then this new h5wasm plugins repo. It'd be great to have these all be community efforts. And that's already sort of under, I mean, I think that the people at Silix, I don't know how to pronounce it, SILX kit are interested in helping with this too. So that might be a good place to put it. And then people who know about licensing, because obviously licensing is important, and I haven't put a lot of time or effort into making sure that the licensing is appropriate. I have been sure to copy all the licenses for the source files that I've put into these things so far when they've come from other places that have licenses attached. So in conclusion, it seems like it'll work. This was just sort of a proof of concept. The plugin infrastructure, I was worried about some of the roadblocks, but with changes in Chrome, it looks like it'll work. But there's some work associated with adding every new plugin, so this will take some time. You have to compile the dependencies from source in emscripten, so there's some flags that have to be passed that are special. When you compile and it runs local tests, you have to compile them to JavaScript and then have Node run the test, for instance, instead of compiling executables and directly running them in the operating system. So there's just little details that have to be taken care of. And sometimes this happens automatically, and some CMake systems are set up for that and some aren't. And then people who are doing troubleshooting will have to learn sort of debugging in environments they may not be used to, like opening up the browser console in Chrome and looking at detailed tracebacks from the WebAssembly. And then, you know, little decisions like choosing between exporting all symbols or the more targeted export. And yeah, that's it. I'd like to thank the people who have made lots of contributions externally, people who like getting the libhdf packaged for CMake, and then people who made h5web, of course, and they contributed a lot to h5wasm to get it compatible with h5web. So I appreciate that a great deal. And they added TypeScript types. That was a lot of help too. So thank you very much.
Thanks very much, Brian. So now we have some bollocks. Excuse me. Now we have some time for questions. I'll also do this so that we can see if there's any more questions online. So anyone in the auditorium? Okay, yeah.
Brian, thanks a lot. I mean, this is a really good news, because before I came here, I heard there were problems with LZ4, but you seem to have fixed them and opened the way to adding, it seems like any filter now. The one thing you were missing there's also another thing that I think using h5wasm is the visual code extension, yeah? So this is also heavily used. It's already installed.
Oh, that's true. That one might be used more than any of the other ones.
Yeah, it's been installed over 10,000 times already.
Oh, wow.
Yeah. But no, this is really excellent work. And I think, I mean, I did have a question. I forgot. I had a question. One was, there was a limit to the size of the files you could read. And I remember Axel telling us that you were working on this way of streaming the data in so as not to have to read the entire file. I think the limit was 2 gigs or something, because it depends on the browser cache or something. Eh?
It depends on the file system limitations of emscripten. I think it's a 32 up to now it's a 32-bit sort of emulated operating system. So there are limits to the maximum file size from that. I think it is 2 gigabytes right now. But yeah, I haven't worked on that streaming option. If you're using it as a VS Code extension, it's possible you could do that, because yeah, that's a different type of environment. So I haven't solved that problem yet, but that's something that we could talk about more.
I will say you have room for h5wasm organization on GitHub. I mean, you have a few, then that would make it clear. So you have the plugins with the core library all together.
Yeah.
And then anyone can join as you want. Like.
Yeah, that's true. That's a good idea.
Thanks. Any other? You can use this one for the time being. We can see that might have low batteries or something. Let me check. Hey, Brian?
Yes.
Hey, I was wondering, could h5wasm access files from S3 or not?
Yes.
Okay.
There's an issue if you have what is it? It's there's some browser security limitations. So you have to have access control set up properly on the server so that it allows cross-site reading of the files. There's been some discussion about using S3. There's also sort of a lazy file loader that can be used with it that can stream the files into the browser. It's a little bit complicated to set up, and you do have to use that one in a web worker instead of in the main thread. But there are some more advanced ways you can use it where you can stream the data in to the browser side. So probably, I can't remember having, I remember there were some issues with making sure that you could bypass the browser security restrictions to read in files, because sometimes it has to have the correct headers coming from S3, and I can't remember if they come in automatically or not, or if you have to do special settings in your bucket.
Right, I guess it's for those cross-site restrictions.
Yes.
Okay, cool.
I don't know if you see the question and answer, Brian, but Loic says that it's a great effort and we will contribute within the limits of our capabilities.
I can say the same. I will contribute within the limits of my capabilities. I see there's a question from Mark about szip compression. We can certainly add that to the list of things to try. If it's straightforward, then it'll be added pretty quickly. So yeah, I'll give that one a shot. I don't know if there's licensing issues with that one. So I know that it's not included in the base of HDF5 libraries for the licensing reasons, but.
Yeah, not anymore. There's libac, and that has a permissible license, and so that's what we use in the library now instead of the original szip.
Oh, okay.
So any other questions here or online? Over there, okay.
Hi, Brian. It's Hector. So I have being used now h5wasm, not only for visualizing images, but also to creating Nexus files. So I'm going to give even a presentation tomorrow and about the tool that I have been working on. And one question that I have, I got the limitation that you mentioned about the 4 megas, and now have moved to 8 megas while trying to write big files as a test. And I wanted to ask you if it is possible to. I have managed to create like data sets, big data sets, set big limit, and then store by chunks. And with this way of writing, I can write down big files, and it's working. But I have to set up a maximum limit. But if I am streaming some information and I don't know this limit, I don't know if there's a way in which we can create some kind of a stream just to start putting data inside without having to specify this maximum limit. I don't know if it's possible to do it with h5wasm.
Are you talking about using it in the browser context or in Node or?
I am using it in Node.
Oh, okay. You can directly write to the underlying file system in Node if you use Node rawfs. Are you using that or?
No, right now I'm just using the writer as it is. I don't have it here in mind, but I have to put the whole data into memory and then put it down into file. And if this data is too much, then it crashes.
Oh, okay. Yeah, I think if you're using the memory file system in Node, you probably also have the same limit just because that's a WebAssembly limit. But there is a way to use the Node will let you Node with the Node package for h5wasm should let you write directly to the file system if you use Node rawfs. So if you use the right package and set things up, it should just automatically write to the underlying file system without having to write it to memory. And there's actually a trick you could do with that in the browser too, because Chrome allows you to access. There's a special flag. So if you write a web app in a certain way in Chrome, you can mount a local folder and read and write directly to files from that local folder. I haven't put a lot of time into that, but I've done some proof of principle stuff on that, and that works too. So you could use this as a sort of a locally deployed Chrome app. The other browser, Firefox, has specifically decided not to go down this route because they're sort of anti-progressive web apps. But I think, yeah, if we should be able to solve that problem for you. I think you should be able to write directly to the file system.
Okay, I think I will get in contact with you. So, maybe we can do it together. Thank you.
Okay, thanks. Any other questions or comments? Okay, so I guess not. So let's thank Brian again.